Yeah, it's all sorted. It's all sorted.
Yeah. Cool. So, for those who turned up late, the sun will get you if you sit there, so don't sit there. Cool. Thank you everyone for coming for the Brisbane Laravel Meetup for January. This is our second session of it. So I'll be MC tonight. My name is Ben. I am the technical lead at Scout Talent. If you haven't heard of them, that's okay. They don't do PHP, so they don't count. Bit of housekeeping before we start with people who are here. Toilets, so we have men's there, ladies just around the corner. Fire escape is clearly marked over there. I'd like to respectfully acknowledge the Turrbal and Yugara traditional owners of the land on which this event is taking place, and elders both past and present. I also recognise those whose ongoing effort to protect and promote Aboriginal and Torres Strait Islander cultures will leave a lasting legacy for future elders and leaders. A reminder that this meetup is a respectful community of professionals with a code of conduct. Our meetup's code of conduct is available on our meetup page. This is the COVID safe event plan for those who are here. Those at home, stay safe. So if everyone can make sure they have signed the QR code, which is clearly labelled near the beer. Stay 1.5 metres away from everyone. The chairs have been spaced. 1.5 metres, please don't move them. And if you cannot maintain a 1.5 metre distance, please wear a mask. I would like to thank iSeek Plant for generously providing the venue and sponsoring this evening's event. iSeek Plant is Australia's largest online construction marketplace, servicing thousands of equipment, rental and construction services businesses across the country. Some special thanks to people who have helped make this today possible. We have Matt Peters, Chief Operating Officer, for his support of the Brisbane Laravel community. Thank you, Matt. Bronwyn Freak and Lorraine Westwood for their assistance in organising the event. And Jacob Powell for his efforts in providing event marketing. And of course, thank you to our three speakers tonight, Greg, Jess and James. We always need more speakers, so if you have an idea or a request for a talk, please have a chat to Greg or myself tonight, or put it on our GitHub. Agenda for tonight, so 6 o'clock, we've just been through at 6. The next talk is going to be Greg, first up, talking about how to feature flag effectively. Then we're going to have a quick break for some food and beverages. After that, at about 10 to 7, hopefully on time, we'll have Jess talking about how to build a service container from scratch for fun and profit. And lastly, we have James, who is going to talk about using Inertia to supercharge server-rendered applications, and finally a chance to network at the end of the day. If people would like to move just a little bit closer, that might make it easier for people who need to talk a bit louder, like myself. Thank you. So for those at home, lean in a bit. Cool. First up, Greg.
Afternoon, everyone. Thanks for coming along. We had a really great number of RSVPs this time. I'm really happy that the event's growing. It's only our second crack at this, and there's a lot more people here than there was last time. So yeah, tonight I'm going to be talking about feature flagging. So if this is going to work, yeah. So I'm Greg. I'm the head of software engineering at iSeek Plant, and I've been involved in the software development industry for something around 20 years, and I'm passionate and obsessed with workflow and continuous improvement. Bit of a plug, we're hiring at the moment. We've got a couple of roles open for PHP developers. We've got a product manager role going. There are a number of roles in the business. We're scaling up. If you are looking for work or you just want to have a chat with anyone, you'll find a lot of iSeek Plant people floating around. Come and see me or James or Gus on, our head of sales behind here. We've got Ollie, who's head of product, Bronwyn obviously, who looks after all of our recruitment in-house. So, what is a feature flag? Essentially, it's a piece of configuration that allows you to switch out functionality in your application. This is about the simplest way that you can implement feature flagging in your apps. But this talk wouldn't be terribly valuable if all the people just talk about that. So I'm going to go through some of the things that feature flagging can enable, and then talk a little bit about how we've enabled that at IC-Plan. So hands up anybody who has had a branch open on one of their projects for more than a few days. Okay, cool. Keep them up if you've had a branch open for more than a week. And more than a month? Okay, everyone can have their hands down now. I think everyone who has been building software for any period of time has dealt with long-lived branches and knows what hell that is to deal with when it comes to merging it. You have merge conflicts, other integration issues. Unfortunately, while we'd all really like to work in really tiny increments, the reality of the work that we do is sometimes we just can't merge work from our branches back into the main line because it's just unfinished, or it hasn't been approved by product marketing, or it's too big to fit within an iteration. So yeah, it's sort of a bit of a pain that we have to deal with. Feature flags give you the ability to completely ignore that reality and work as if you can just chunk your work down into the smallest possible increments. The way you do that is you create a feature flag and you build your functionality behind that feature flag. You can be deploying that to production. None of your users are going to see it. And then when it's time, when it's completed, you can throw a switch and that functionality immediately goes live. Another sort of enabling thing that feature flags give you is canary deploys. If there's anyone who's hung around DevOps people for any length of time, you've probably heard of canary deploys. Typically, this is done with infrastructure. You'll have two environments, a current environment and a next environment. You'll have some kind of load balancer sitting between those two that you can use to direct traffic between those environments. And you start with a small percentage of your traffic going to the next environment, and you slowly ramp that up while you're monitoring performance, conversion, bug reports, and so on. That's really quite difficult to set up unless you know what you're doing. And it has some disadvantages in that you can really only canary an entire release. You can actually do the same thing with feature flags by funneling traffic to a percentage of your traffic to a variation inside of your feature flagging tool. And that allows you to canary deploy multiple features concurrently. So you can have 10% of your users going to feature A and 20% of your users going to feature B, and you can monitor those two things concurrently in the same deployment. We're probably all familiar with beta testing. So this is releasing a version of software to a subset of your users. The software might not be finished yet. It might still need some work, but you want to get some feedback from some users before you go live with the rest of your customers. Beta testing is a little bit similar to canary releases, but instead of deploying to a percentage of your traffic, you're deploying against targeted users, so people with a particular domain name on their email addresses or a particular subset of your user base. We use this all the time for sprint reviews. So we'll have completed the work and have it deployed in production behind a feature flag, demo that work to stakeholders, get the all clear, throw a switch, and that functionality is then live for our customers. So we can be beta testing and demoing with live data and real production loads. You can also use this for like an opt-in, opt-out treatment. So if anyone's used any of the Atlassian products, you've probably seen this. Occasionally you get a pop-up saying, hey, we're releasing a new version of this feature. Do you want to opt in? When you click OK, that's telling some feature flagging system that you as a user want to be opted into that feature for beta testing. Cool. So this is the really big party trick. So multivariate testing or A/B testing. This is a way of experimenting with your users at scale. So you can start using your application as a big science experiment. Most of us, I think, work in a complex problem space where it's pretty difficult to impossible to know for sure whether something's going to be received well by your users. And sometimes you've got competing ideas about designs that are all completely valid. And what you really want to do is find out whether or not your users are going to enjoy the feature that you're building. So what you can do with multivariate testing is split your traffic across multiple versions of the same feature, and then measure whether or not measure which of those versions is giving you the best outcome in terms of goals completed, conversions, and so on. So a purely contrived example, let's say you've got a purchase form and we want to find out whether or not green buttons motivate people to purchase more than blue buttons. You can create a green button variant and a blue button variant and split your traffic across those and then measure what the conversion rate is of that form based on which color button they click. And probably for a lot of us who panic a little bit about things going wrong in production, kill switches are an amazing benefit that you get from feature flagging your application. So again, in complex systems, no amount of testing can prepare you for real production data. Real user load is a difficult thing to simulate, and your users are going to confound your validation rules and break your softwares in ways that you could not possibly have dreamed of. If you roll out a feature behind a flag and you notice that something's gone wrong, you can turn it off like instantly. And if you do a continuous deployment process like we do at IC Plant, you probably don't necessarily need this, but there's still probably 15 minutes from identifying the problem, getting a PR up for everyone to review, and deploying it. With a kill switch, you can turn it off in a second as soon as you see a spike in load or suddenly people not converting on your funnel. So those are the few of the benefits that we've realized with feature flagging over the last 12 to 18 months. And I wanted to dig in a little bit into how we've gone about implementing that. So this is the example from earlier in the deck. This is where we started, and we ran with this kind of functionality for 18 months. And this does allow you to do that code behind a feature flag or separate deployment from the release of features really, really well. As long as your deployment environment is mutable. So if you're using Forge, you can go into the environment file, you can change the running environment settings for your application, and this will get you a long way. One of the biggest problems we ran into was we started moving towards Laravel Vapor, which has an immutable environment. So if you change configuration, you have to perform a redeployment. Once you're doing that, you're no longer feature flagging, you're just deploying feature branches. So we went looking for an alternative solution that would allow us to reach into a running production environment and affect change. We chose Launch Darkly to do that. Of all of the offerings, it had the most reasonable PHP SDK. The PHP SDK is not really a Laravel style library, so we had to write a bit of a wrapper around the outside of it to leverage some of the benefits of the framework. And this is the implementation that we landed on. So we have a global feature function you pass the feature flag into as well as a default value. And you can see in this example, if the new sign-up flow is true, then display the sign-up new display template, otherwise display the old sign-up template. This feature function is reaching out to Launch Darkly, and Launch Darkly is telling us whether or not we should turn that feature on for that particular user. You can run that function in almost any part of the code. It gets a bit weird if you try and run it inside of routes. We've tried it to try and swap out controller versions. It gets a bit weird because we need the request to have been processed before we can actually understand who the logged in user is, for example. And you have to jump through a few hoops if you want to use this feature toggle inside of like a queued job. But if you're using it inside of controllers or views or service classes or most parts of the framework, you can just call feature and ask Launch Darkly to tell you whether or not you should turn it on or not. Underneath this all, there's a fairly simple service provider, and it will detect whether or not the user is logged in, and it will use one of a couple of strategies to identify that user. So normally, we deal with register anonymous user. Most of our users on our main directory are anonymous users that don't have user accounts that they can log into. We need to be able to identify that user in a way that persists across multiple requests. And we run a relatively high session timeout at IC Plant, so we can just grab the session ID and use that as a way of identifying the user. You could do all sorts of other things. You could fingerprint the user and create a UUID for them or whatever. It doesn't matter, it's just a string. We can then merge in additional attributes that we want to attach to this user. So for example, is the user using a mobile device? Are they using a desktop device? What's their geolocation? Are they located in Brisbane or in Sydney or in New York? Basically anything you can get a hold of off the request or on the server, you can inject into this user. For authenticated users, it's pretty much the same process. We just say that they're not anonymous, and we include a first name and a last name and an email address. And you can use first name, last name, and email address to target people inside of a LaunchDarkly interface. And just on those sort of custom attributes, you can also use those to target users. So if you wanted to, for example, target all users in Brisbane who use a tablet, you can set up rules like that inside of LaunchDarkly, and it will read the information from the user information that you've pumped up to it via this function. So this is what targeting kind of looks like inside of LaunchDarkly. This is a live flag that we're currently running for a feature. I chopped the top of it off, and I can't quite remember exactly what feature this is, but we have a rule that says if the user is in the segment office, display the flag as true, so turn the flag on. The office user segment is just basically anyone who has the IP address of our company network. If that rule evaluates as false, it'll move to the default rule. And in this case, we're doing a canary rollout. So we're doing a percentage of the traffic is receiving the flag, and a percentage of the traffic is not receiving the flag. And we can move that slider up as we gain confidence that this feature is working the way that we expect it to. And when you make these changes are pretty well instantaneous. So experimentation, A/B testing, multivariate testing is kind of built on top of all of this. So we have another global function called track. And track will record any number of metrics or goals that you want to score for in your application. And you can have many of these track calls in a given request. It will batch those up, and then through a piece of terminable middleware, we'll shunt those calls up to LaunchDarkly after the user's received the payload off the page. And LaunchDarkly is able to understand cross-request activity of users. So in this case, a user might have gone to a sign-up page and evaluated that they're going to receive the new sign-up flow. They've then filled in the form, and now they've landed on this store method, which is storing the data that they've entered into that form. LaunchDarkly can more or less automatically match the person who originally evaluated that flag to the goal that they're tracking. So when you pull this up in LaunchDarkly, it looks a little bit like this. So this is a feature flag where the variations are new design versus old design. The first column there is the number of conversions over the number of people who have received that flag. The next column is the conversion rate, and then we've got a confidence interval. So in this case, we're not quite sure whether or not this feature is actually going to fly. The confidence interval is between what the old design receives and maybe as high as 6% improvement in conversion. LaunchDarkly is doing all the stats for you, so you don't have to understand student t-tests or any of that. It's all just taken care of inside of the interface. And when a flag is determined to be winning, you can then, LaunchDarkly will tell you, and then you can just funnel all your traffic to the winning variation and then start building another variation. So I want to talk a little bit about best practice. These are the sort of best practices that we've discovered through research and also through our own usage of flags over the last couple of years. And the first thing is, if in doubt, make a flag. They're really, really cheap to create. It's basically just a little conditional in your code and a little bit of configuration inside of whatever tool you happen to be using to achieve this. Because you never really know how big a feature is going to get. It might be a feature that you think you can crank out in 20 minutes and it turns into something that takes you like 20 days. You never really know if that little database optimization that you did is going to take your SQL Server down or cause some other problem. So because they're really cheap to create them and work behind them. Even if they're on from the start, it doesn't really matter. The second best practice is don't reuse old flags. Now we haven't actually run into this problem because we haven't ever reused an old flag, but there's a cautionary tale of an investment company in America that some people might have heard of called Knight Capital, So they were a US investment firm that specialized in high volume automatic trading. And they reused a feature flag and then deployed code to 7 out of 8 of their production servers. When they turned that feature flag on, they had 7 servers that were running the new code and 1 server that was running code that had been defunct for over 2 years. Now, you can go and read about exactly the details as to what went wrong. I won't bore you with them now. But the actual outcome was effectively something like an infinite loop that was buying stock on the US stock exchange. They torched something like $450 million US in 45 minutes. So don't reuse feature flags, and don't manually deploy software by copying stuff to an FTP server either.
Can't roll that.
The other thing I think is to avoid long-lived flags. Most of these tools will have the ability to have what they call a permanent flag. And they sort of pitch this as a feature that you can use to enable functionality for a subset of your users if you're doing some kind of bespoke change for somebody, or to manage whether or not users receive features based on their license and so on. Whilst the targeting and the segmentation capability in these tools is pretty good, it's not a full-blown programming language, so baking parts of your domain into some external tool is probably not a great idea. And the last piece of advice is don't keep flags around for any longer than you need to keep them around. They're cheap to create, but they're technical debt the second you introduce them into your code. And if you don't routinely go back and clean them out, you're going to have your code is going to be littered with conditional statements. And every one of those conditional statements is making a remote request to a server to retrieve some information. So once you're done with them, pull them out. I've seen teams in other businesses create a Jira ticket the second they create a feature flag, and they put a due date on the Jira ticket that's like 30 days after the flag goes live, just to remind them to go and pull it out. LaunchDarkly actually does have the ability to inspect your code and identify areas of your code that may contain feature flags and give you automated tooling to pull them out. We haven't actually used them because we've kind of gone off the beaten path a little bit with how it works. Maybe one day if we get bored, we might turn around and build something like that. So there isn't really a great Laravel solution for feature flagging, but we've built a tiny little library for LaunchDarkly, and if people are interested in doing this with LaunchDarkly, and there's enough of you out there, I can have a chat to Matt and see if he's okay with us open sourcing this tiny little library for you. No promises, but happy to have a conversation about how we've gone about doing this. And I think, is that going to work? No, battery's not flat. Questions? Any questions? Yep, shoot.
How do you deal with automated testing around feature flags? So when you're using something like LaunchDarkly, where...
So we do it a couple of different ways. I guess the primary way of doing it is we have the ability to override the result of that flag. So you may have noticed, let me just pull the zip back a little bit. Where are we? There we go. So we have the ability to insert a default value in there, and we have the ability to override on a flag basis to say, hey, don't go and talk to LaunchDarkly, just do whatever the default happens to be. And you can sort of manage that through the container. You can sort of convince the service class that's making this all work to give you an answer that you expect to give. This is probably another reason why cleaning up flags is a good idea, because in like best practice, I guess, you should be testing all possible combinations of all flags of something that's running in production. And that's probably a combinatoric problem that's going to explode in your tests. But yeah, service container is the short answer to that question. Anyone else? Sure.
If you test the same feature flag multiple times in one execution, is it cached internally after the first one, or does each call make another request to LaunchDarkly?
That's a good question. I'm not 100% sure how the library works under the covers. I've kind of glanced over the performance. I think you're kind of maybe getting at, is there a performance sort of?
I guess so.
Yeah. So LaunchDarkly is intended to work with systems that can maintain a persistent connection to their service and stream flag data out. Obviously, in PHP, that's not really practical. It's not how our execution model works. So they actually provide a Docker container that contains a program called LD Relay. And so you deploy that document, it's written in Golang, it's super fast, and it maintains a persistent connection to LaunchDarkly, and it's writing all of your feature flag information into a DynamoDB database. So if you have to reevaluate flags, it's a couple of milliseconds to Dynamo. You're not actually reaching out and hitting like a server in the US every time you make a request. So we haven't noticed any performance issues. We tend not to evaluate the same flag more than once on a page. It doesn't really.
Yeah, and if you were, it's probably twice, and so it doesn't matter.
Yeah.
60 times.
Yeah. If you're doing it 60 times, that'd be a really interesting experiment to run. And if we do go down the open sourcing route, maybe run a test on that and see how that goes. Anyone else? How are we for time? Here we go. Shoot.
One last question. How much did LaunchDarkly pay you?
None. Nothing. Zero. No.
Cool. All right. Any last questions?
Anything from the stream?
Nothing from the stream.
Okay, cool.
Cool.
I wasn't
Thank
that
you.
interesting.
Cool. Thank you very much, Greg.
Jess, thank you everyone.
So we're going to break for about 20 minutes now, just to give everyone a chance to grab a drink, grab some food, say hello to everyone who's come along. But we'll start about. Oh, sorry. Yeah, so we'll probably come back about 10 to 7 for talk from Jess. Cool. Thanks. Sorry.
So food's just going to be through the.
Doing great.
He's drunk.
How many beers?
Get him some water. I'll get some back at
All right.
It'll move around depending if you've got stuff blocking the screen.
Oh wow!
Yeah.
Nice.
As I found out with Greg's, it's not safe just to keep it
By
around.
saying it moves around, you mean
I
you
never
move it
actually,
around?
I didn't even consider that.
It just bounces like a Windows XP screensaver.
That would be awesome.
You're gonna get really fortunate with them.
I'll show you about if you did that.
You were trying to do.
Alright, you ready? Cool.
I guess so.
Alright, I'll make sure everyone knows.
You want to try and stay?
Stay here.
Yeah, right there.
It's all me coding, so I won't actually have a reason to go over there.
Alright. So, just for those who are here, just grab any last food or drinks. We're going to go pretty much back to back with these talks. For anyone who try not to fall out. For those who turned up late, could please remember to scan in on the QR code. If you haven't done it already, that'd be fantastic. Thank you. So up next is Jess talking about service containers.
Building service container.
Building a service container from scratch, which we're all very excited to hear. So thank you, Jess.
Hey everybody, my name is Jess Archer. I'm a full stack developer. I'm currently working part-time in the medical industry and part-time for Laravel Shift. I'm a podcaster, so I have co-host a podcast with JMac called the Base Code Podcast. I've also been a guest on the Laravel podcast and the Happy Dev podcast. And I've spoken at Laracon AU and Laracon Online. But this is actually my first meetup talk. I kind of went the wrong way around with that. So I thought I'd take this opportunity to do some live coding. Now when I agreed to do that, there wasn't going to be many people and no live streaming. Now there's more people, so a bit more pressure, but I'm still want to, get my live coding chops up, so we'll see how it goes. Now, can everyone see that okay? Is that size all right? There's a few chairs. Obviously, we can't move them closer together, but if anyone needs to scooch forward into another chair, then hopefully we'll be okay. But sing out if it's way too small. All right, so today I'm going to talk about building a service container from scratch. Now, I'm not encouraging you to actually build your own service container. There's already great ones out there, and if you're using Laravel, as I imagine most of us are, you've already got a service container. So the point of this talk is to actually teach you about the service container you already have, and to demystify it, and to show you that under the covers it's not actually magic, it's generally pretty straightforward. So I'll be starting today with a pretty basic project. I've got a command here that will just show, this is a plain PHP project, so no Laravel. I've just created a few files to get us started. The main one we're dealing with is this container file. And also just quickly I'll show you that the only packages we're pulling in are PHP and Mockery, and I've set up a few auto-loading things. So it's basically from scratch. So if we jump into, open up Vim, go to our container test, up to the top of it. All right, so let's start by talking about the problems with using new in your code. It's in when you use a new keyword to new up an object instance. There's a few problems with that. One is that you can't swap it for a mocked version in a test. As soon as you write new something in your application code in your controller, you cannot swap that. You can't make it a singleton if you need to, unless you add extra code to your class to make it a singleton. You can't depend on an abstract interface. So say you want to say, oh, I just want a mailer. I don't care how the mail is sent. I just want a mailer. When you new up something, you need to new up the actual concrete class you need. You also can't use dependency injection. So any constructor arguments you need to pass in. So say you've got a mailer that needs to know the SMTP server and the port and all that. You've got to provide that all when you new it up. And if you need that in multiple places, then you're defining that in multiple places. So this basically means we don't have inversion of control. So if you've heard of an IOC container, that's basically where you're centralizing the newing up of all your classes into one central place. So this whole talk I'm going to run via a test suite, which I've already written. And our first test here is to basically say that if we try and new this up, this SMTP mailer class, if I go to the definition of it, its constructor wants a server parameter, and I'm using PHP 8's ability to define our stuff in line here, which is pretty sweet. So if we try and new this one up, it's going to have our too few arguments exception, and that passes because we did get an exception saying too few arguments. All right, so the first thing our container needs to do is it needs to be a singleton itself, because we don't want multiple containers flying around that have a bunch of stuff registered to themselves. So our container offers us the ability to make other classes singletons, but to make itself a singleton, it can't do that. So we need to use more traditional methods of making it a singleton. And for those of you who don't know what a singleton is, it's when you only have the ability to have one instance of a class in memory at one time, basically. So the only thing I've done so far, I did say this was from scratch, but the one thing I have done is made our container a singleton. So here's our container class. I've made the constructor private, so we can't new this up, and I've created a static getInstance method. Now this is the same naming that Laravel uses, and I've tried to use the same naming as Laravel so that it's more familiar. And all we're doing here is saying that if there's no static property called instance, we'll new it up, and then we'll return that. So the second time we call this, it will already be in existence, so it will return it. So if we go back to our test and run that one, that will pass straight away. All right, so now let's get into some actual fun stuff. This is the top. All right, so we're getting our container instance. This test is basically saying that we can provide instructions for resolving a class. So as we said before, when you've got a class that needs help to be instantiated, it needs parameters. The service container is great for doing that. So we can basically say here we want to bind for the SMTP mailer class. These are the instructions to actually give that SMTP mailer class. So when we go further on, in our application code, we can say container, just make me an SMTP mailer class. I don't care what you've got to do it, just do it. And the important thing here is that every time we call make, we will get another instance. So you can see here I'm calling make a second time, and we're asserting that we're not getting the same instance. So if we run this now, it's going to fail because we haven't done anything. So if we go back to our container class, the first thing we need to do is create a bind method. And in Laravel, the first property they call abstract, which is a string. And the second property is a closure, which we need to import, called concrete. And the bind method doesn't return anything, so we can put a void return type on it. And this is how simple it is. We're just going to say this bindings abstract equals concrete. So we need to create that variable. So we'll just make a protected, sorry, it doesn't need to be protected array bindings. All right. And then we also need a make method. So this lets us bind something into the container. Now we'll create a make method, public function make. And this time we're asking for the abstract, but it's going to give us the concrete. So this will return mixed because we can technically return whatever we want here. And we're just going to say return this bindings abstract and put brackets on the end. So we're calling the function we're passing in. So if we go back to our test now, and you remember we're binding this, we're providing instructions for how to resolve our SMTP mailer, and then we're making it and asserting we have an instance of the SMTP mailer, and then we're doing it again and making sure we have a different one. So if we run this test, we get green straight away. Now, next test. We can also use a string for a key. So you may have noticed in Laravel, sometimes they use these lowercase strings to define their services. So in this case, we've got mailer. This is handy if you just want to give a string name to something where you don't want to define like a specific class. So you may have noticed that we accepted a string as our abstract property, so we can actually just run this and it works out of the box. We don't even need to do anything extra to get that to work. If we go to our next test, we can also bind an interface to a concretion. Now, I've put a note here to say that just because we can use interfaces doesn't mean we always should. One trap I've fallen into in the past is feeling like I need to create an interface for every single thing I do so that I can swap out the actual concrete class. The problem I found with this is in my application code, unless you're building like a framework or a library, if you're just building a regular application, most of the time you're not going to be swapping out things all the time. So it's an unnecessary complication that doesn't generally pay off. So I, most of the time in my application code these days, don't actually use interfaces of my own that I've
7
created.
p.m.
Thanks, Siri. Okay, so here we're binding a mailer interface, and this time we're using a short arrow function because they're cool. And we are asking it to give us the mailer interface, and we're asserting that it's an instance of the SMTP mailer. We haven't made any changes to our container yet. This is still running because this is just literally returning a class. So what have we got so far? We've got an IOC container. We now have a central place to define the logic for instantiating our services. We have the ability to depend on an abstraction or even an arbitrary string name. And we have the ability to substitute a mock version in a test. Because if you bind something in the service container, you can bind it again in a test and it will just replace the existing binding. So this code here, aside from our singleton logic, is all we need for a service container. But there's a few extra things that a service container lets us do. So let's make it a little bit cooler. So the first one we've got here is that we can pass a concrete class as the second parameter. So sometimes we don't need to provide instructions on how to resolve a class. So in this case, we've got this array mailer. If we go to the definition of this, it doesn't have a constructor. Our service container doesn't need help to instantiate this. It can basically new it up itself. So in this case, we're basically saying we bind a mailer interface and we want to get an array mailer back. If we run this now, it's going to fail because it's expecting us to pass in a closure. So let's go and fix that real quick. If we up here say that we will accept a string as well, and then down here, if we store this variable as our concrete without the brackets on the end, we can say if our concrete is an instance of closure, then we will return we'll call the closure and we'll run it. Otherwise, sorry, it's gone the wrong place. Otherwise, we will return a new concrete. So, if we run this one now, this one passes. Because basically we've just said now that if we don't pass in a closure, we're just passing in a string, let's just try and instantiate that. And so with that small change, we have that. All right, next one. We can also make classes we've never seen, aka zero config resolution. So if you look in the Laravel documentation, they talk about how the container is a zero config resolution. You can resolve something from the container even if you've never registered it before. And this is really handy if you have a class that doesn't need help to be resolved, but you want the ability to mock it in a test. You don't have to bind anything to it in the first place. So if we run this right now, it's going to fail. And in this case, the error is a little bit obscure, saying bindings must not be accessed before initialization. And that's because we didn't really do any type checking of what we had. So if we go back to our container, this one here, we can say, what we're doing here now is saying that if there is no binding for this particular abstract we pass in, let's just try and resolve the abstract that was passed in as it is. So if we run this test now, this one passes. Small change, big result. All right, we can recursively resolve. This one's where it gets pretty cool. So in this case, we're newing up our container again. In this case, we're binding our mailer interface to the SMTP mailer, but the SMTP mailer itself needs help to be instantiated. So we've separately provided instructions on how to resolve the SMTP mailer. If we run this at the moment, it's going to fail, saying that we didn't pass any operations into the, any arguments into the SMTP mailer constructor. Because basically at the moment, it's just trying to say, oh, if we have a mailer interface, new up the SMTP mailer class. We haven't told it yet to go look this up in our in our existing bindings. So if we go back to our container now, all we need to do to make this one work, sorry, just going to go back to the test. That's right. All right. So in addition to this make method, Laravel has a build method. So we say public function build, and the parameters for this can be a string or a closure. And in this case, we're passing in a concrete. It's returning void. Sorry, it's returning mixed. And then this code here we're using, that's doing our building, we're actually going to move this just down into here. And then at the top here, what we want to do is say that if our concrete is an instance of a closure, or the concrete is equal to the abstraction, then we want to build it. So we want to call that logic from before. So we will say build our concrete. However, we need to return that as well. However, otherwise, we want to make it. So we're calling ourselves recursively. We're calling this method from within itself to say, try and make this class, because it wasn't a closure and it wasn't one we're going to try and build straight away. We want to look back into the container to see if the container can resolve it again. You might think this is going to end up in an infinite loop, but the fact that at the top here we're saying that if the concrete has never been heard of before, we're just going to set it to the abstract, and this check here makes sure that if that's the case, we try and build it straight away, then we're pretty safe. So if we go back to our test and run this test, this one passes. So this is pretty handy, but let's make it even cooler still. So our next test, we can also bind a singleton. So as we mentioned before, singleton pattern is a handy way to say, I have this particular class, generates a service, and I only want one of them to exist. So the common example is a database. I need to make database queries all throughout my code base. I don't want 10 of these making their own separate database connection and consuming all my database connections. I just want the same one every single time I call for it. So we have this extra method here called singleton. If we run this at the moment, of course, it's going to fail because there's undefined method singleton. So how do we make our container do singletons? Well, under our bind method, let's create a singleton method. And it will accept the abstract the same as before. It will also accept a closure or a string of the concrete, and it will also return void, same as our bind method. And this is actually going to, actually it's not going to return, it's going to defer to our bind method. So we're going to pass it the abstract, we're going to pass it the concrete, but we're going to pass it a third flag, which is true. So in Laravel, the bind method actually has an extra parameter called shared, which is a Boolean. And by default, it is false. So we need to store this shared variable somewhere. So in Laravel, the bindings array is not actually just key value abstract to concrete. It's actually a multi-dimensional array. Sorry. Okay. So we store the concrete as we were before, but now we also store whether or not it is shared. And then when we are making it, we need to also make sure that we are pulling that now from the nested array. Let's go back to our test for a second and try and run this one, because we've changed the error message now. So instead of singleton not being found, it's saying failed asserting that two variables reference the same object, because we haven't done anything yet to store our instance and return that same instance every time we ask for it. So let's now go and do that part. So in our make method here, instead of returning the object straight away, we're actually going to store it. And likewise, if we make it, we're also going to store it. Oops, sorry. We need to store it because we need to now check that if our shared property is set to true for this abstract, we need to make sure we store that. So we're going to say if is set this bindings abstract, because it might not actually exist, so we don't want to access it straight away, and this bindings abstract shared, whoops, shared, I'm just going to say whether it's truthy or not. So if this condition happens, we want to store this in a new property we're going to call instances, an S on the end, important. Go. All right, so we're going to store that. So we need to make sure we create that one first. So we'll just copy this one and call it instances. And so now we're storing that. We can return our object as we were before. Now this still isn't going to do anything. If we run this test, it's still going to fail because we're still returning a new thing every time. So we need to add something to the top of our make method very top that just says if this instances, if this instances abstract, we'll say if it's set, so if we have a instance already stored, we can just return that straight away. Not do anything else. So if we run this one now, we get green, fantastic. So now we have the singleton pattern. Now, oftentimes with a singleton, you might want to make a class a singleton, but you don't actually need to provide any instructions for it. You might want to new it up outside the context. You don't want your service container to new it up. You want to new it up at the time you're binding it, which is common in tests. So in a test, you might create a mock version of your class, and then you just want to pass in the instance of it rather than passing in instructions. So in this case, we're newing up our instance outside of the container, and we're just telling a container, for the array mailer, use this instance. And if you've ever used the swap method in a Laravel test, behind the scenes, it's just calling container instance to swap out the instance in the container. So as usual, this one's going to fail because there's no instance method. This is another really, really quick win because all we need to do is say for our instance method, we still need to take the abstract, and then we're going to take our instance. I'm not going to return anything. Oops, sorry. And then we are going to save that. Instances. That's all we need to do, because our other logic here is already checking if that exists. So this test should just work. And it does. All right, next one. Test it binds a singleton by class name only. This one's actually what I was talking about before. So in this case, we have a class that doesn't need any help to be instantiated. We don't need to provide the second parameter to say this is the class or these are the instructions for it. So at the moment, if we run this, it's going to say that we haven't provided the second argument. So 1 passed when it was expecting 2. So how can we make our singleton where we just say, this is the class I want to be a singleton. It doesn't need any help to be resolved. Just make it a singleton. Well, we can, on our singleton method, allow us to accept null as the second parameter. Oops, sorry. And default it to null. And then we need to do the same for our bind method. Do you reckon there's anything else we need to do? Nope, that just works automatically because we've already set up our container down here that if it doesn't know, if it doesn't have a concrete for it, just try and resolve the abstract. So that one small change, we get that feature for free. Almost free. All right, test that as a dependency injection. This is the last thing, and this is probably the coolest thing. Now, in this particular case, we want our container to make us an API mailer. We haven't bound anything, but if we look at our API mailer class, it has a dependency of this API class. And if we look at our API class, it doesn't need any help resolving. So if we try and run this out of the box, it's going to fail because it's going to try and resolve, it's going to try and new up our API mailer, but our API mailer needs help. It needs to know how to resolve the API class for it. So, as I said, I'm not going to code this one manually because it's using PHP's reflection library, which is a little bit gnarly, so I've prepared something earlier that I can steal from. If we have our build method, you'll notice that we've got our concrete instance of closure, return concrete. I'm just going to copy all this stuff and I'll show you where it goes in a second and we'll walk through it. All right, so here's our build method. So here's where we're returning new concrete. This is where the problem lies because we're not telling it, we're not handling situations where it needs arguments. So let's replace that with this code. Now what we're going to do is we're going to new up the reflection class for our concrete. If that fails, we're going to throw a binding resolution exception. And if you've used the container, you've probably had a binding resolution exception before. It's when the container says, I don't know how to resolve the thing you want me to resolve. But assuming this this is a concrete class, it exists, it's a real class, this should pass. Now we can ask the reflector, is this instantiable? So this won't return true if it's an interface, and we can throw another binding resolution exception saying that our concrete is not instantiable. Assuming that passes, we can get the constructor. We can ask the reflector to give us the constructor. Now if there is no constructor, we can return new concrete straight away as we were before. But if there is a constructor, we can ask the reflection library to give us the parameters of the constructor. Now, we're going to defer to this resolve dependencies method to actually resolve those. And once we have all of the instances required, we're going to ask the reflector to new up an instance for us with those arguments. So if we jump down now to the resolve dependencies method, we've passed in all the parameters that our constructor needs. We're going to loop through them all. As I've said here, this is a much simpler version of what Laravel does. It's handling things like variadic arguments and a whole bunch of other scenarios. So for our example, we're just going a little bit simpler. We're asking the reflection class, what is the type of our dependency? Now this type will return either a reflection type or a null. If it's not a reflection named type, or it's not if it's a built-in as well. So if it's a string or pretty much if it's a string or an integer or anything like that, or if it's not a named type, we can throw another binding resolution exception. But otherwise, it must be a class that exists in the system, and we can defer, again, to our container itself to make that. And as we've seen, this will go recursively, and it will go back through this resolve dependencies. So if our API mailer needs an API and our API needs something else, and so on and so forth, it will recursively go through until everything's resolved or a binding resolution exception has been thrown because it doesn't know what the hell it is. So we return that back, and as you saw, we're asking the reflector to renew it up for us. So if we go back to our container test, we're now asking it to make this API mailer. It's never seen it before. It has a dependency. Does it run? We get green. So that's a basic service container with dependency resolution and reflection. There's a bunch of other things that Laravel's container can do that I'm not going to go into because I feel like this gives us like 80% of what we need to do with 20% of the effort. So other things Laravel's container can do is contextual bindings. We can say when this particular controller asks for this thing, give us this one. When this other one asks for it, give us this one. It can do primitive bindings. We can actually say if you encounter a string called $server, give it this. We can extend our binding. So if we're binding something somewhere, we can extend that binding and decorate that class. So if something is being bound in a plugin, we can extend that binding and inject a decorated version of that, which is pretty cool. It also does aliases, extra dependency resolution cases, like I mentioned, variadic arguments. It also fires a bunch of events that you can hook into, and it's got tags for resolving multiple things at the same time. How are we doing for time?
Couple of minutes.
Couple of minutes, okay.
You can take as long as you want, I'm fascinated.
All right, cool. So that's everything for this test. That's a container. I wanted to show you a little bit of, to kind of make it a bit more concrete for everybody. I want to jump to a controller I've made called this home controller. So as I said, this is a plain PHP project, it's not Laravel. I've created a home controller, and here I've got a constructor that's got dependency injection for this PDF method, which we can see is under app support PDF. If we jump to that real quick, we will see that all it does is return a PDF version of the string that's passed into it, and it's not actually PDF, as you can probably tell. But so our constructor here is receiving that. Again, we're using PHP 8, so we don't have to actually do that whole dance of this PDF equals PDF, all that sort of stuff. We're automatically promoting that to a protected property on this controller. So our index method is saying, PDF service, please generate me hello. So what do we expect? We expect that we're going to get a PDF version of hello. So if we run this one, one thing I'll show you before we run this is I've created a front controller here that loosely implements something similar to what Laravel probably does under the covers for routing. So I've defined, you can ignore the vendor stuff, but we're saying for this route, we want to use the home controller's index method. If there is no route, we can just do a not found because we're not doing anything real here. And we're going to ask our container to make this class, and then we're going to call its method. So our container is going to new this up. It's going to inject our dependency, our PDF class for us, and echo this out. So if we run this one in our browser, we get a PDF version of hello, which I think is pretty cool. Now, the thing that this allows us, as we said before, is we can swap this out in a test. So if I go to our home controller test, we've got test it can swap dependencies. So in this particular case, I'm setting up a mock version of our PDF class. I'm saying it should receive the generate method and return a mocked PDF response. And I'm using this swap method, which I've created, that mimics what Laravel's swap method does, which is just get the container instance and pass in an instance for this abstract, and then return it. And then I didn't want to write everything required to do like Laravel's, this get stuff. So I'm just asking the container to make our controller and call the index method, and then I can assert against the response that we're getting the mocked PDF response, and we get that. One extra thing I'm hoping we can show, if there's enough time, is really quick to show you how facades use the container. So if you've ever used the facade in PHP, they look a little something like this. You've got a static function called getFacadeAccessor. The thing you return from this is a string. The thing you return from this is just a reference to say, look this thing up in the container, resolve this from the container. So in this case, our PDF facade, we're saying, we've had to alias it because it's got the same name. We're saying, for our PDF facade, return our PDF service. So if we went back to our home controller, instead of doing this stuff, we could actually say PDF generate. And we just need to make sure we're using the facade version instead. And if we run this one, that doesn't work. Why does that not work? Facades with an S. Refresh that. So we get our PDF version of hello with a facade. Now, if we go back to our test, our home controller test, we can mock via the facade. Now we can still mock via our container if we want. The facades give us this extra ability to say the facade should receive, which we saw from mockery, and return a mocked PDF response. So if we call our container method again with our index method, we should get our mocked PDF response now that we're using a facade. I don't know why I've done this twice here. Let's just get rid of that. I don't think we need it. Run this one. I'm not running an assertion. Oh, because I've marked the test as skipped, because it doesn't pass until we start using the facade. All right. So that's pretty cool. Now just to really quickly show you behind the scenes what a facade looks like. Real quick, this is it. All right, so our facade, this is our abstract facade that our other one was resolving. You can make a facade with two methods. Call static. Anytime we call a static method on a facade, it basically proxies it through to the underlying class. We just ask, what is the facade accessor? So our string from our container. If it's not resolved, resolve it, and then basically proxy that method through to the underlying class. And then our should receive method, which basically tells our facade, you're no longer going to resolve to the proper concrete class, you're going to resolve to a mocked version of itself. Again, we can basically just say here, if there's no resolved instance, or if the resolved instance is not already a mock interface, then we're going to ask the container to give us an instance, and then we're going to mock it. So we're going to swap out our resolved instance with a mock, and then we're going to return the should receive method on the mockery object. So we're basically proxying now our should receive through to mockery. But any future calls to this facade now, we've swapped out our resolved instance for this now to have our mocked version instead. So once we've done should receive, all of our code that's depending on a facade is now using should receive. It's very similar to using dependency injection. There's two ways to solve the same problem. Some people like one, some people like the other. I think they're both really cool. So that's my talk. Are there any questions? I probably went through that super fast, but if anyone has any questions about the container, I'll attempt to answer it, but the container does more than I could ever hope to understand.
So obviously VI over Emacs, but tabs or spaces?
This is a great question.
I know Sam's got an answer for that. But
I always prefer using a standard over my personal preference.
Cool.
Personally, I think tabs are actually kind of better. It's like one character instead of using an arbitrary number of them. So I prefer tabs as a personal preference. However, I much prefer using a standard like PSR12 over whatever silly personal preference I have. Does that answer your question?
Yeah, that's a perfect answer.
Cool.
Cool. Any other questions?
Anyone else? Cool.
All right, well,
oh,
thank-
hang on.
Do you think you should almost never have new within the application?
I would say that if you've got new in your application code, it's probably a smell. I mean, there's certainly cases to break every single rule, but I think because we have zero config resolution, if you just always resolve via the container, you can always swap it out if you need to and get all the other benefits of it. So I personally don't new things. If you're doing like an integration test and you want everything to run through to the end, then I mean, there's no police that are gonna come and say you can't use new in your code. But yeah, for me, I kind of it's just a general thing I prefer to do. Oh, the other one thing I really wanted to really quickly show you, assuming we have time, is Laravel's container. I wanted to show you Laravel's container, its container real quick. So the make method on Laravel's container is actually an alias for the resolve method. And if we go down to that, there's a bunch of stuff here around, firing resolve callbacks, all this event stuff. But when we get down to it, it's, if there's no concrete, it sets the concrete to get concrete, which is basically saying if there's no abstract, return the abstract. So there's a little bit more abstraction in terms of creating methods, but is buildable is basically saying, is it a closure or is it the concrete? Build it, otherwise make it. It's all there. Then we've got extenders for doing all that stuff. But most of what I've shown you is what Laravel does. I've just made it a little bit simpler. And one last really cool thing is if we go to the helpers class, you may have seen Laravel has the app helper. You can see under the covers, Laravel's app method is saying if you don't pass in a class you want it to resolve, just return the container get instance, exact same method that I used. Otherwise, resolve the instance of the container and make that abstract. You can pass in parameters, things we haven't covered, but at the heart of it, using Laravel's app helper or app instances that it injects for you in any cases, you're getting a container exactly like the one I showed you today, just Laravel's one has extra cool stuff in it. So, yeah, it's cool. Good?
Good.
Thank you.
Thank you very much, Jess, for showing us how easy it is to live code live. So that was really fantastic to see. James is up next with using Inertia to supercharge server rendered apps, I think.
Something along those lines.
Something along those lines.
Has inertia in it, so.
Hasn't it? So, yeah. Do you need this?
I will. Unless everyone doesn't want to see. What I have to see. Yeah, I'll do that.
And for those who weren't watching live stream, there were a lot of clap emojis. So it was really good talk, Jess.
Is that going to be available on YouTube straight away, or?
I'll refer to my tech guru.
Should be, yeah.
Cool.
Because I need to watch that back in half speed.
Yeah, I know, right?
5 times.
Which way do we go?
This thing works. Cool, that's working. Alright, I kind of feel it's a little hard to follow a talk like this, so it's pretty fun. Mine has a lot less live coding and a few more slides. But hello everyone, thanks for coming along tonight. And for those online, thanks for tuning in. Tonight I am talking about InertiaJS. I'll cover what InertiaJS is and how it works, but I'd first like to start with a little backstory for how we came to be using InertiaJS. And a little bit about what that journey looked like for us. Obviously there is time for questions at the end, but for those online, just post them whenever and Ben will read them out on your behalf at the end. So let's start with who I am. My name is James. I'm a team lead and I'm a full stack developer here at IC Plant. Sometimes I write about ideas or solutions I've had to problems on my website, and I'm also on Twitter if that's your thing. So whether you're building similar applications or not, I think giving an overview of the types of things that we've had to consider when deciding to adopt Inertia may help you decide whether it's something for you, but it may also highlight things that we haven't had to consider when deciding it as a technology that we want to use. So we build a handful of customer-facing applications. We have a portal for our searchers, our suppliers, and our partners. And we have a lot of internal applications that support our platform. And these are usually some form of administration tool. Each of these applications is what we call a macro service. I spoke about this in more detail at our last meetup, but this basically just means that they are a focused monolith, and they may expose an API, a front end, or both. And all of these applications are built by a relatively small team of full stack developers. And I mention that because the UI is built and managed by us as experienced, but we're by no means expert front-end developers. And lastly, all of the applications that we've got, bar our searcher application, all require authentication to be used. So we're a Laravel shop. All of our applications, big or small, are built using Laravel. And historically, we were building our front ends with a mixture of Blade, jQuery, and Bootstrap. And as time went on, we did make some efforts to try and modernize our front end tooling. We shifted using JavaScript classes for our jQuery. And we rolled our own version of code splitting to try and make this work better with our JavaScript classes. But it was around mid-2019, we began moving towards Tailwind, and we stopped using Bootstrap. And by late 2019, we were beginning to use React. Now, it didn't take long for us to fully adopt React, and very soon we were quickly building all of our new work using React. At this point, we were really enjoying React. It was vastly better than jQuery. I mean, jQuery has its place, but I mean, React is great too. Pretty much. Every time we have to go back and look at the legacy stuff, it's a little bit painful. But we were using server-side routing to load our views, and those were in turn booting our React components. We wanted to push more towards an SPA experience. You see, we were already building 99% of our front end in React, and this would help us tip that scale a little more and remove this unnecessary duplication where we have to string up these views, which are just simply there to boot our React components. It also meant that all of the existing APIs that we'd already built to interact with these React components could still be used. SPAs can come with some additional bonus features. You get the option of things like PWAs, offline support, you get the opportunity to statically host the front end, amongst other things. But to get all of this, we would have to move the routing for the front end to the client side. Data fetching would almost exclusively have to happen via APIs. We would no longer be able to route via a controller and just pass props in like you can with Vue, with the Blade views. And we would need to consider how we have to manage any persistent state as we move around our SPA. And finally, we need to consider if we need to recreate any browser behavior, like our backwards or forwards navigation, and how that might interact with our components, so we make sure that the state of those is restored correctly. So what was it about SPAs, or what was it that we actually wanted? Well, we want the front end to be entirely in React, and we don't want to be managing routing in two places. It would be nice if we can continue to pass data into our components like we do with Blade. So inside your controller, fetching any data that you need and then passing it down. This would reduce our need for a route that would then be rendering a view or a component that would then need to use APIs to go away and fetch more data. And we'd like to get that single page experience where we aren't rebooting React on every page change. And this would also help us keep things a little snappier on the client side. So enter InertiaJS. This is a library that allows you to quickly build modern single-page apps using classic server-side routing and controllers. Let me just pause for a minute and ask a couple of questions. How many of you have heard of InertiaJS? Yeah, about half of you. And how many of you have used InertiaJS? Far fewer. Okay, cool. So you know a little bit about what it is, maybe. Some of you obviously never heard about it before. So that's kind of cool. Okay. So before I talk about how it works, why don't I just show you what it looks like in action. So here I have an application that is loaded. I'm browsing around on it at the moment. It may be a little bit hard to see, but as I navigate between each page, the application is not performing any full page reloads. There's no white flash as React boots up again on each page change. And as an added bonus, we were getting a nice kind of progress indicator that runs across the top that I'm sure you're familiar with. So what's actually going on with Inertia? Well, on our first request, it's something that is akin to your traditional server-rendered page. We're loading HTML, we're loading all of the assets that we need, and anything else that is required to load and boot that page. On any subsequent request though, we are simply returning JSON with the information that Inertia needs. Taking a practical look at what that means, here's a look at the network tab for the first page that we load. On the right, we've got the HTML response, and then on the left, we can see all the assets that are getting loaded in when we first boot this up. Ooh, that jumped too fast. When we navigate to another page though, you'll notice that we just get JSON back. This tells Inertia which component we want to move on to and any props that should be passed into it. So how do we get started with Inertia? Well, first we need a base view. And this is what your typical base view would look like. We are loading our CSS and our JavaScript, and then we use the add Inertia blade directive, which will allow Inertia to render their root div and work all the magic that they need to. Next, we need to tell Inertia where to find our components. If we remember back to the network tab, we saw that the Inertia response tells us which React component to load, but we have to tell the Inertia library where to go and find that component. In this example, we are importing the app component from Inertia, and we pass two props to it. The first one is the initial page. So when we first boot our application or a user first loads it up, they need to know which component to load in. And this is handled for you by Inertia. They take care of all of that data set that goes on their root div. You don't have to worry about that. The second one though, resolve component. When it comes to loading or resolving the page component that we've asked it to, we need to tell Inertia where to go and find that component. Now an example like this would typically live in like your app.js file or something similar. And in this case, we are telling Inertia that our page components can be found in our pages directory. If you want to enable code splitting for your components, then this is quite easy. We just have to update how we resolve the components. We start to use dynamic imports rather than the require syntax. Now this does require a Babel plugin, but you get the gist of it. And finally, we need to pass the components and the props for each page to use. If we take this fairly typical Blade example, we are loading a machines index view, and we're passing down the machines that we want to show on that page. Now for us, prior to Inertia, this would have just loaded a machines index, the view would have just booted a machines index component and then passed the machines in as a prop. To swap this over with Inertia, we just need to use the Inertia render method and pass in the name of the component that we want to use and any props that we want to have passed into it. Now, as you can see, the syntax is very natural and familiar to that of a traditional Blade view. So with installation complete, how do we go about using Inertia? First, you'll need a way to move between your pages. This Inertia link is effectively just a wrapper around Axios. It sends some special headers with each request that tell the server-side library to give us back a JSON response. Now the API for using it is exactly the same as if you were using an anchor tag. And as long as the page that you're navigating to also returns an Inertia component, then this is just a straight swap for any of the existing anchor tags that you've got. That said, it's not just for GET requests. Perhaps you need to send a POST request to log out. You can even go so far as to send data along too if you want. Now, I've not personally used a link for sending data like this, but I can certainly see a use case for it when you're doing something simple like toggling a state of something. Maybe you're enabling or you're disabling something. And perhaps then a nice follow-on from that point is how do we handle form submissions or sending data if we're not using the Inertia link? As I mentioned, you could use the Inertia link, although it's not typically what we do. And perhaps more commonly, you would use the Inertia client instead to make your requests. I hope you guys can all see that. But here we have what I would view as a more typical way to work with forms. You have the form itself, which contains all of our inputs, and a submit button for when you're ready to save your changes. When the form is submitted, we are calling a handle submit function, which in turn uses the Inertia client to post to the user's endpoint with our form data. Now you can use form data as I have in this example, or you can just use a regular object that you might already have in state if you were using controlled inputs or control components. However, in a recent addition to the library, Inertia can now automatically detect if your visit includes things like files. And when you're working with files, you do have to work with form data like this. It's what is required to send multi-part form data requests, and that's what's needed via XHR if you want to upload files. So Inertia will automatically detect if there's any files, and it will convert to the form data object when it's needed to. Of course, you have all of your other HTTP methods available, like put, patch, delete, and so on. In another recent update to Inertia, they introduced a form helper. This is currently not available for React, but support is on its way. It's currently available for Vue, and it basically aims to abstract everything to do with a form away from being something that you have to configure and set up. Here's an example of what it does look like in Vue. So at the top there, we've obviously got our template, and down the bottom there, we've got what's actually going on inside of our Vue script. We can see that the form helper is providing us with bound or controlled inputs. It's handling submissions for us. It does the processing states while we're waiting for that request to be fulfilled. And it will handle all of the error handling and validation for us as well. So this helper looks to provide a number of useful utilities that I've often found myself implementing with or alongside Inertia. Now, it wouldn't be a cool SPA without some nice transitions or progress indicators when we move between our pages or when we submit a form. But in all seriousness, progress indicators help give feedback to our users that say the page isn't hung or isn't broken when you've performed an action. In Progress is a small library that provides the progress bar that runs along the top of your page during a request. Now they provide a plugin to make it quick and simple to get this set up and running in your project. It's literally just an npm install, and then you run an init call there, and it's good to go. If we want to configure it a little bit more, then they do expose some arguments that you can pass down to control things like the delay, the color, whether or not they should include the default CSS, or In Progress does have an optional or an alternative layout where it uses a spinner rather than a progress bar running across the top. But if you want a little bit more control, or you want to implement your own custom indicator, then you can do so using request events. So during the Inertia request lifecycle, Inertia emits events when the request starts, when a progress event occurs, which is when you're uploading a file and we get a progress back from the server saying how much of that has been processed, or when the request has been finished. Now, what do we do when we have multiple components that need to share the same piece of data? Inertia Share is a way for us to provide common data to all of our pages. Take errors, for example. If your submission or your visit contains validation errors, then we'll want to display those to our users. Or flash data, giving the user some feedback about the action they've just taken. But there's no limitation to what you can share. A couple more use cases for this might be your feature flags, or library credentials where you don't want to hard code these into a component or chuck them on the window. Although you should be mindful that anything that you do decide to share will be loaded and passed in for every page that you visit. With our application no longer being server rendered with each page visit, what do we do if we deploy a new version of our application while someone is already browsing with our old bundle? Well, we use asset versioning. When we tell Inertia what version of our application we're using, it can detect when this changes. Now, the canonical example is to use something like a mix manifest, but you can return anything that you want. When Inertia detects that the version has changed, rather than hot swapping your components out, it will perform a hard visit to the next page, like a hard, it'll navigate to the new page and you'll get the loading symbol and everything will be downloaded again. And this gives you a natural way to refresh your bundle when it updates. This is jumpy. What should you do when you are making requests or visits to the same page and you only need to reload some of the data? This is often useful when you've got a filter or list on a page, but you also have other data that gets loaded in. When you update your filter, you want the list to update, but you don't need to go and reload all of the other data that is sitting on that page. Partial reloads are a way to only fetch a subset of the data that was initially loaded in. Partial reloads can be used with any Inertia visit, an Inertia reload, or when using an Inertia link. In all three examples there, we are just asking Inertia to reload the user's prop. But for partial reloads to be most effective, we need to be lazy loading our data. And we do this by wrapping all optional data inside of a closure. When Inertia performs the visit, it'll determine which data is needed and only evaluate the closures for the data it needs. And this can significantly increase the performance of your pages where you have costly, or in some cases optional data that you simply don't need to refresh every time. So what makes Inertia so great? I don't believe that SPAs are actually hard or complex to build, although I've got no real experience building these commercially. However, if you've got existing applications that have routes, views, and some React or any front-end framework in them already, then leveraging Inertia to transition to an SPA is incredibly simple. My team recently had a project where we were reskinning and revamping our entire supply portal. This was an application with about 20 different views, and all of these views had some different level of interactivity or discrete actions that needed to be performed. The application was all Bootstrap and jQuery, but using Inertia, we could go and swap the pages out one by one, rebuilding them with React and Tailwind. And that's one of the other benefits of Inertia. If you ever need or want to break out of the SPA, you can. You just use a regular anchor link and you're back into a traditional Blade application. And the install is incredibly quick. It's 2 npm packages and a composer package. You also get a nice separation between your front end and your back end. The back end will handle all of your routing, your business logic, the persistence, data retrieval, and so on. And as a back-end developer, nothing has really changed for you. You are still working in the same framework, doing the same things you've always done. You just return it in a slightly different way. The front end then is purely about the aesthetic of your application and presenting this information to your users. We avoid the duplication of things like our routers and so on. You also don't have to build out as many AJAX endpoints. When we're returning an Inertia component, we'll usually be passing in all the data that that component needs. It won't need to boot up and then go away and fetch more data from an API. With the use of partial reloads, we also have a way to refresh any specific bits of data once we've already loaded a page if we need to. By hot swapping components, we only have to boot React once. And additionally, sending the updated component and props as JSON significantly cuts down the amount of traffic we have to send over the wire when we're navigating to a new page, if we think in a more of a traditional Blade view sense. In production, with some of our simpler pages, it's not uncommon for us to see page load times in under the 250 millisecond mark. Having worked on large JavaScript projects before, bundle sizes can usually creep up quite quickly. Adding code splitting is literally a one-line change and a Babel package, but this only further aids in keeping the application snappy and quick to navigate. Now, this presentation wouldn't be complete without addressing some of our pain points. Hard visits aren't often something that you need to do. This is an SPA after all. But when you do need to perform one, there isn't an intuitive way to do this. You could use location.href or something similar, but we opted to utilize the same mechanisms that Inertia uses when it needs to perform hard visits for asset changes. And we've done that using a response macro. This returns a 409 response, and it uses a header that says what page we want to go to. And this is the same mechanism that Inertia uses when it's performing hard reloads or hard visits for asset changes. But that's it. We've not run into any other walls or pain points. We've built about 5 or 6 different production applications now. And these have been a combination of new builds or existing projects where we've gone back and we've ported them to use the Inertia library. However, if you do run into limitations, it's important to remember that at the end of the day, it's just JavaScript. There's nothing special about the Inertia library. If you need or you want to use Axios manually, there's nothing stopping you. Go for it. And at any time you need to, you can break out of Inertia. There's nothing jailing you in. That's it. Any questions? Go.
That was awesome, thank you.
Thanks.
I've used Livewire, and I was wondering if you've played with that and how you think it compares with Inertia. They both solve similar problems of making it so you don't need to have an API, but
I think they did. Well,
completely different ways of
I'm
doing it.
familiar with Livewire. I've really not used it other than watching a few Laracast videos or some stuff from Caleb about it. So I guess I don't have a lot to say about them. I think they are very similar. Obviously, Livewire is trying to get you away from JavaScript and back into managing them in your backend. But I suppose Inertia, and correct me if I'm wrong here, but I think Inertia is more trending towards the, if you're using React or any other front-end framework already, and you want to get that SPA feel where you kind of just slide through to the next page, if you will, I suppose Inertia allows you to do that, whereas Livewire, I suppose you're still performing hard visits to each new page. Maybe you have the benefit though that you don't have as large a JavaScript bundle, so it's still quick and snappy. But I guess, yeah, they're two different ways to solve a similar problem, I'd say.
Cool.
Yeah.
I was also curious why you chose React over Vue, given that Vue is kind of like the default option for the Laravel community.
That's a great question. I actually come from a Vue background. It wasn't until I started here that we stopped and had a conversation about whether we should be using React or Vue. I think Vue's great. I have nothing against Vue. But I think the job market for React is probably a little larger. At least from what I've seen in Brisbane, there are typically far more React jobs than there are Vue jobs, and I think that speaks to, at least from a hiring perspective, when you want talent and you want them to be able to come into the office every now and then, hiring locally, you kind of have to be at the mercy of whatever the most popular technology is, and for us that was React. That said, I think React and Vue actually share a lot of similarity. When you actually stop and look at the component lifecycle, they're all doing the same things. It's just a little syntactically different. I honestly don't think one is better than the other. It's just, yeah, from a purely hiring perspective, we found React was going to give us more options. So that's why.
Thank you.
Anything else?
At least if you say React, you don't have to clarify whether you mean Blake Vue or Vue.
Yeah. I was writing this out, and every time I was like, oh, I have to avoid putting Vue and Vue together, so yeah, cool.
We've got a question from the Plang Muppet. How does Inertia,
Great name.
how does Inertia work in a high latency environment?
I suppose that's a good question. We don't really have that problem, so I can't speak to that. We use, one, we use Vapor. Two, our infrastructure is hosted inside Australia. Three, we're pretty fortunate in that we have a relatively okay internet speed. I mean, people will say what they will about NBN, but it's better than some of the speeds that you'll see in other countries for sure. So I mean, for us, it's not really a problem. All of our users have pretty high-speed internet connections, or if you're way out rural, then you're probably hopefully using something like mobile data, and it's a little bit quicker. But I think if you're using code splitting and you've booted the first page of your application, you've done most of the legwork at that point. You've downloaded most of your assets, and anytime you're navigating to a new page, you're only getting exactly what you need. The code splitting allows us to load only the components that we need at each time. So you're not downloading megabytes worth of JavaScript. If you've got a huge application, you're literally only downloading what you need. So whether or not it makes it any faster to get that data, I don't think is the case. However, you're being very efficient about what you are getting. You're only downloading what you need. Did you have a question before?
I was going to ask about accessibility issues, because spas are notoriously terrible for accessibility.
They are. Honestly, it's not something we've dived into fairly heavily. I think accessibility is important, but I think there's also a real cost to building highly accessible applications. For us, a lot of our users, because of the market that we're in, we tend to not have users that have disabilities. That's not an excuse to not be doing it, but we are a relatively small team, and we've been trying to move really quickly. At this point, we're trying to scale up really fast at the moment and get stuff to market a bit quicker. But I don't think there's anything about the Inertia library that stops you necessarily from building accessible things. If you're following best practices, if you're using your ARIA labels and you're building out your React components appropriately, I don't think that there is anything unique to Inertia that stops you from having an accessible SPA. That said, I've not spent time
The only thing
navigating.
that really jumped out to me initially was the Inertia link
Mhm.
component, and you're not sure if that's a button or a link or...
Yeah, that said, we typically don't use, we aren't using the Inertia link really for sending post requests. It's an option there, and I mention it purely because you can use it, and I can see some use cases where you might want to. And as far as the inertia library goes, or at least the inertia link goes, if you are sending a post request, that it is rendering it as a button. And then any extra props that you pass onto it that may not be like specific to the inertia link itself do get passed down into whatever element is rendered. So again, if you're providing some accessibility labels, then they will end up getting rendered onto that button that is there. Otherwise, at the end of the day, you can wrap that button if you want to in another component or another element, and you can provide those labels as you need to. Yeah? Anything else? Cool.
Cool. Thank you, James.
Thank you, guys.
So that concludes the talks. Well, you're still on screen, so.
No, you're not.
Isn't it?
Okay.
Okay.
I'm
So
gonna
thank
line
everyone
up.
for coming tonight. Especially big thanks to our speakers, and I think Greg and Jess are happy you settled the hard questions for James. Well done. Good answers. What else was I going to say? Thanks, Riley, for your help. It's been really great help on the YouTubes. Stick around for a bit if you want to. We still have some drinks and stuff, but we'll kick you out fairly soon. Kidding. Yeah, thank you for coming along. Thanks to all speakers and everyone who helped make tonight a success.
And if anyone wants to